Okay, so we are going to talk about logarithms today. A logarithm, again, is an inverse of an exponential. It's a inverse way that we can represent something that's an exponential equation. So we can see in the middle of our notes here that we've got an exponential equation, b to the y equals x. And these are all just placeholders for numbers or other maybe variables. Okay. So if I have something like 2 cubed equals 8, I can rewrite this in what's called logarithmic form. The base for the exponent is the base for the exponential. This little number here is called a base. So this would look like log base 2. And then this guy here, so this is called the base. This guy here in parentheses is called the argument. The argument is whatever my exponential equation is equal to. So for my little example, this is equal to 8. And then our log is equal to whatever the exponent would be. So we'll use logs when we don't know what the exponent is, okay? If on your calculator you ever wondered why it says a log here on the TIN fire, kind of just to the left of the 1, there's that e to the x, 10 to the x key, and then right above in blue that says log. You ever wondered what that was for? That's for this, okay? We're going to use this when I don't know what the exponent should be. This is another way to represent that, okay? So the first thing I want to talk about today is how to be able to convert between these two forms, log form and exponential form. That honestly is the hardest part of this, is getting that sort of that conversion down, okay? So if I have 3 squared equals 9, and I want to write this in log form, the base stays the same, so it would be log base 3 of 9 equals 2. Then for b, this would be log base 4 of 64 equals 3. I want to make a quick note on sort of placement of my numbers here. We are used to writing exponents, and we know that exponents kind of live up in the air. It's called superscript. I always remember it because they're up in the air like Superman. And then the 2 and the 8 here are like on the ground, right? If we think about way back in like kindergarten, first grade, when we used to get paper that had like the writing little marks on it, right? So I knew how to write my letters. The 2 and the 8 live on the ground. The 3 lives up in the air. When we write logs, everything lives on the ground except for the base for the log. That lives sort of burrowed a little bit. It's like kind of half buried. This is called a subscript, okay? It's a little below. I point this out because one of the things that we sometimes have a hard time with when we're working with logs is making sure that we are writing clearly what we intend to write. So if you also put the 8 down here, you are not writing log base 2 of 8, you are writing log base 28. If you don't put the 2 as a subscript, then that's not log base 2, that's log of 28. Okay, so just make sure you are very clear with what you are writing on your papers for me. For C, 125 to the 1/3 power equals 5. So this would be log base 125 of 5 equals 1/3. It's equal to that exponent. And then for D, log base 8 of 1/2 equals negative 1/3. We can take exponentials and put them into log form. We can also take stuff in log form and put it into exponential form. So those are the next couple problems that we'll see. Log base 2 of 16 equals 4. This means 2 to the 4th equals 16. For b, let's see, if I were to rewrite this, this would be 5 to the second power equals 25. I want you to notice as I'm pulling these out of log form and rewriting them into exponential form, they make sense, right? 2 to the fourth power, that is 16. 5 squared is 25. Right? These should make sense. For C, 49 to the 1/2 power equals 7. This would be the square root of 49. Is that equal to 7? Yeah, these should make sense. Okay. Where we want to start using them, and we'll get into this a little bit more tomorrow, is when I maybe don't know what that exponent is. So this would be, if I were to rewrite it, 3 to the x equals 1. Problems where I don't know what the exponent is where we tend to use the logs. That's sort of the purpose of them, if I don't know what the exponent would be. Particularly if the exponent's not going to be something nice. So for example, if I had maybe 4 to the x equals 17. There's not a nice value that I could plug in for x there, like not an integer number I could plug in for x that would give me 17. I know 4 squared is 16, so it's got to be bigger than 2, only a little bit bigger than 2, but I don't know what exactly. Okay, so that's where I would use a log base 4 of 17 to be able to figure out what that exponent is. That's why we care about logarithms. That's why we use them. On the next page. We're going to sort of set the stage for where we want to take this stuff. So today our big focus is just practicing this log form, converting between exponentials and logs. Where we're going to take this is kind of what we looked at with that 4 to the x equals 17, being able to figure out what is the exponent. We'll use the logs to be able to determine that. Okay? So the idea is, I want to know what would that exponent be. So 2 to the what equals 8. 2 to the third, right? So if I were to write this in log form, it would look like log base 2 of 8 equals 3. When I say log base 2 of 8, this is what I'm asking. 2 to what power equals 8? 2 to the third. How about for B? What would A be equal to? I like the negative. -3, right? -2 would be square it. We want -3, so we cube it. So A would be -3. How about C? That one's -2. Yeah, we want to flip it. So we started with a fraction. Now we'll have a whole number. So the negative tells me to flip, and then 3 squared gives me 9. How about D? It is going to be a fraction because I know I need to take some sort of root of this, right? To get from 64 to 4. Anytime I'm going from a big number to a small number, I should think a rational exponent, and it's going to be the cube root, so 1/3. Very good. So big idea for today, swapping between those two forms, okay? I would like you now to work on your practice at the bottom of page 12. I am anticipating we will finish this with ample time to spare. So we will check these once you guys